3.74 milliamp over 25. So 3.74 divided by 25. 0.1 496 Siemens. What is R pi of 2? So-called the dynamic input impedance of the second stage. R pi of 2 is beta over Gn of 2 is equal to, so you flip that number and 10 times it by 100. 668 ohm. 668 ohm. Okay. All right. Everything is complete in here. Now I'm starting building the model in order to analyze. Assume capacitors are short, so we assume that they're adequately large, so they will be considered short. You will have this situation here. Caps, short circuit. So you have VI, short, you have 3K, you have 12K, B1, you have R pi 1, 126 ohm. You have E1 straight to the ground because of the CE. Then you have here this current source. Then you have collector of 1. That current source is VBE of 1. But notice VBE of 1 is the same as VI. So this current in here, IC of 1, change of the current, this is signal current, is equal to minus GM1 multiplied by VBE of 1, or minus GM1 multiplied by VI. Because VBE and VI are the same. See, this potential from here to here is the same as that potential from here to here. This is a ground, same as that. That's the same node as that. Now, what is next? From here, you start drawing the models. From here, 2K goes to the ground, that guy, to the collector. So put the 2K here. 2K. Name this node from here to there, the signal VCE of 1. That's the signal at the collector of stage number 1. Because if you tap the oscilloscope here, you have a signal. You tap it here, it's an interstage voltage, kind of in between. You tap it there, that's the final end. So this is your interstate voltage, VC1 here, VCE1. Then it goes to see where. From here, goes to the next stage. It's a PNP, but just imagine it's an NPN. It has its own, so let me do it in a different color, maybe. It's bad. Nice color, this one. B2, R pi 2, which is equal to 668 ohm. E2, imagine, straight to the ground, although it goes through that capacitor C, but it's considered ground, no signal. Then goes to another current source, here, arrow, and guess what? This is VBE of 2. But VBE of 2, notice, is equal to VC of 1, because that point is VC of 1. VCE 1. Then you have that current, IC of 2, is equal to minus GM of 2 multiplied by VBE of 2 of the second stage, which is this voltage. And it goes into, finally, 1K. This is the RC of 2. And finally, it goes into RL, which is equal to 4K. And this will be final voltage V out over here. Now, in order to get the gain, all you have to do is to relate this voltage into that voltage. You can do that very fast, actually. What is the voltage in here? Because voltage in here is the VBE of the 2, right? So VBE of the 2, you can say, is equal to, this is VI, minus GM1 times VI, GM of that multiplied by VI, times parallel combination of this one, which is RC1, and that R pi. Do you see that? RC1 and R pi. So you get minus GM1 multiplied by 2K parallel with 668 ohm, okay, multiplied by VI. This is the VI, see? GM1 from VI. So this is the amount of the current which is pumping into input of the second stage. All right, so we got the VB of 2. Then what is this final output, VO? VO is equal to minus GM2 multiplied by VBE of 2 multiplied by 1K parallel to 4K. This is RC2 and that's RL. So if you combine everything together, you make another substitution from here into here, stage by stage, you get that final voltage gain, which is called a V total loaded is equal to minus GM2 multiplied by 2K parallel to 668 multiplied by minus GM, that is minus GM1, sorry, minus GM1 times that, and then minus GM2 multiplied by here times this last one, 1K parallel with the 4K, finished. So go work out that product. But when you're doing, please be careful. Because these are in Siemens S, both of them, students made that mistake, awful mistake in exams. S, they kept this one into kilo ohm. No, convert that into ohms. It has to be ohm. So this is 2,000 parallel 668, maybe like 500, and this one is 1,000 parallel to 4,000 ohm, which is like 700 ohm, GM2, that number, and then that number, work it out. It should be a very large voltage.